Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Standard Level Paper 2, May 2022, Time Zone 2. If you find this video is helpful for your exam preparation or revision, please don't forget to subscribe and let your other friend knows about my channel so you guys can study together. And let's get started. Lithium reacts with water to form an alkaline solution. Determine the coefficients that balance the equation for the reaction of lithium with water. As you can see, here we have 3H, but here is only 2. So let's make it to be 4. So you will have 2 Li here, so we need to make it 2 Li here. And oxygen becomes 2, but here is only 1. So let's make it to be 2. So H now becomes 4, and here H2, and then this one is also 2, so this should be 1. So now it's balanced. A 0.2 gram piece of lithium was placed in 500 centimeter cube of water. Calculate the molar concentration of the resulting solution of lithium hydroxide. So to find the concentration of lithium hydroxide, the formula is N divided by V. We know the V is 500 centimeter cube, which is 0.5 decimeter cube, and we don't know the mole, so we need to find mole of Li or LiOH because they have the same number of moles, so it's equal. So Li is known. Therefore, to find the mole is mass divided by molar mass or the relative atomic mass of lithium. That will be 0.2 divided by 6.94, which is 0.0288. Because the number of coefficients are the same, so mole of LiOH should be the same. So this will be 0.0288, and you will get 0.0576 mole per decimeter cube. Okay, calculate the volume of hydrogen gas produced in centimeter cube if the temperature was 22.5 degrees Celsius and the pressure was 103 kilopascal. So to find volume, we do this from this formula. So let's rewrite. That would be nRT divided by P. We have R coefficient and then a constant, gas constant, and then for T temperature, we have the temperature, we have the pressure, but we don't have the mole. So it's hydrogen gas. As we can see here, hydrogen gas has 1, the coefficient is 1, but for Li the coefficient is 2. So for mole of H2 should be half of the mole of Li. So mole of H2 will be half times 0.0288. You will get 0.0144 mole. So that would be 0.0144 times gas constant times temperature is 22.5 degrees Celsius, so we change it to Kelvin, which is 295.5 degrees Celsius Kelvin, and then divided by pressure, which is 103. But the question here, volume of hydrogen gas produced in centimeter cube. So this will be in decimeter cube. Therefore, we need to times 1000. So you will get 343 centimeter cube. Suggest a reason why the volume of hydrogen gas collected was smaller than predicted. So it means there is some error in the experiment. For example, maybe gas leak, or maybe you don't really use pure Li. The reaction of lithium with water is a redox reaction. Identify the oxidizing agent in the reaction giving a reason. Oxidizing agent, that's always the opposite. If it's oxidizing agent, that will be reduction. If it's reducing agent, that would be oxidation. So I will just write here, this the one that experienced reduction. So we need to calculate what happened with the oxidation state, which one that will gain or increase and which one that will be reduced. So the reaction is 2Li plus 2H2O produce 2LiOH plus H2. So free element or standard state 0, H is plus 1, Li group 1 is plus 1, oxygen we know is always negative 2, and then oxygen negative 2, this one H2, H is plus 1 the charge, and then because of H2, so if it's H1 always plus 1. Li free element, so 0. As you guys can see, for Li here 0 to plus 1 is oxidation, and for hydrogen plus 1 becomes 0. So this one is reduction. So we need this H2O. So H2O is acting as an oxidizing agent because experience reduction in oxidation number. So H2O and hydrogen gains electron. You guys know reduction always gain electron, oxidation always lose electron. Or you can also answer H2O and H oxidation state change from plus 1 to 0. Describe two observations that indicate the reaction of lithium with water is exothermic. Na is very reactive. Describe two observations that indicate the reaction of lithium with water is exothermic. As you know, lithium comes from group 1. They are very reactive. So when it reacts with water, the temperature of the water increase. When the temperature increases is an exothermic reaction. And when lithium react with water, lithium should be melt, so it will produce heat, or heat will be lost to the surroundings, which is also exothermic reaction. Or pop sound is heard because it's very, very, very reactive. So you can choose two of these three. Electrons are arranged in energy level around the nucleus of an atom. Explain why the first ionization energy of calcium is greater than that of potassium. So increasing number of proton will increase nuclear charge, and atomic radius size decreases. So number of proton of calcium is greater than potassium, as potassium comes from group 1 and calcium comes from group 2. And then because the number of proton increases, so the interaction or the attraction between the valence electron and the nucleus is higher, so the atomic radius size will decrease. Therefore, the ionization energy, that the amount of energy to remove the electron, will be higher for the atomic radius size that is smaller compared to the atomic size that is bigger. The diagram represents possible electron energy levels in a hydrogen atom. All models have limitations. Suggest two limitations to this model of the electron. Okay, the first one, you can say lack of representations of sub levels of orbitals only applies to atoms with one electron. For example, is hydrogen. The atom is considered isolated and does not take into account the interaction between atoms. Okay, why is lack of representation of sublevels or orbital? In reality, electrons occupies orbital with an energy level, each with different shapes which affect electron behavior and interaction. Okay, that has different energy levels, but here, as you can see, we don't have different energy levels with different type of orbitals. Okay, and then only applies to atoms with one electron. It does not extend well to atoms with multiple electrons. It's not only hydrogen has one electron, but we have other atoms that has multiple electrons. So each element should show a unique electron configuration, but through this model, it doesn't represent a unique electron configuration because it has some atoms, it has some multiple electrons. The atom is considered isolated and does not take into account the interaction between atoms. It means that it doesn't take into account interaction with another atoms or molecule. In the reality, atoms are constantly influenced by their surrounding, like neighboring atom and electromagnetic field. That's why, for example, you have a different color of transition metals because of it depends on with what it is bonded, like ligand, for example, or other neighboring atom that will make the atom has a different kind of unique behavior. So those four are the answer. You can choose two of them. Draw an arrow, label X to represent the electron transition for the ionization of a hydrogen atom in the ground state. So when the ionization happen, the electron is not attracted with the nucleus anymore because it's being removed. So that would be n infinity. So from ground state, this is the ground state. Okay, so this will be the answer. Okay, it's not really straight, but you can make it straight. And then draw an arrow, label Z. Okay, so we need to label X here. Label Z to represent the lowest energy electron transition in the visible spectrum. You need to know N2, between N2 and N1 are UV, so it's not visible. But now, asking for the lowest energy electron. Okay, when the energy is the lowest, the wavelength should be the longest. So these are the longest. Why? So the wavelength is 656 nanometer, which is red color. It has lowest energy, longest wavelength. And the opposite between 6 to 2. Okay, I'm just giving you an additional information. This one is violet with 410 nanometer. So the shortest wavelength, the highest energy, the highest frequency. Okay, wavelength is inversely proportional with frequency, but frequency is directly proportional with energy. Sulfur trioxide is produced from sulfur dioxide. Outline giving a reason the effect of a catalyst on a reaction. It needs 2 points here, so you give 2 reasons. Increase rate of reaction and lower activation energy. Also provide alternative pathway. The reaction between sulfur dioxide and oxygen can be carried out at different temperatures. On the axis, sketch Maxwell-Boltzmann energy distribution curves for the reacting species at 2 temperatures, T1 and T2. T2 is higher or bigger compared to T1. So T2 is higher temperature and T1 is lower temperature. So the curve will be like this. Let me just make it a little bit better. So this should be like this. Okay, please don't touch the x-axis. And then the other one, because T2 is higher than T1, so for higher temperature it is slightly to the right and has lower peak compared to lower temperature. So it will be like this. Okay, just make it the peak a little bit better. Okay, so this will be T2. For y-axis, labeling fraction of particles, and then for this one is kinetic energy. Okay, so it has more particles for T2, more particles here that have higher kinetic energy. Okay, that's why T2 represent for the higher temperature and is slightly to the right and has lower peak to show that they have more particles that have higher kinetic energy. Explain the effect of increasing temperature on the yield of SO3. Okay, the reaction, I'll just write down here, 2SO2 plus O2 produce 2SO3. And the reaction is exothermic. As you can see here is exothermic because it's negative 196 kilojoule per mole. Alright, so because delta H is negative here, therefore forward reaction will be exothermic and reverse reaction will be endothermic. The effect of increasing temperature will cause the equilibrium shift to left and the yield will decrease. Okay, because it's shift to left, so the yield will decrease because it goes to the favor to endothermic reaction when you increase the temperature. As the temperature increases, the position of equilibrium shift into the endothermic direction to take heat and minimize the effect of change. Okay, so when the reaction is exothermic, the temperature will decrease because it's trying to cool down. And then when you try to increase the temperature, of course, absorb more energy, so it will favor endothermic process. So by absorbing the energy, the temperature being increased, so favor to endothermic process because energy is being absorbed. So that's why it favor to endo. So when it favor to endothermic reaction, the yield will decrease. Okay, increase temperature will increase increased temperature will cause equilibrium, shift left, and the yield will increase. State the product form from the reaction of SO3 with water. There is S there, sulfur. So when it reacts with water, it will produce sulfuric acid. State the meaning of a strong bronzed-lowry acid. So bronzed-lowry acid is a proton donor, okay? And because it's strong, it means that is fully dissociate. If it's weak, so partially dissociate. Nitric acid, HNO3, is another strong bronzed-lowry acid. Its conjugate base is the nitrate ion. Draw the Lewis structure of nitrate ion. Nitrate ion has the localized electron, so it has double bond and single bond. So I will just make it like this because this is ion, okay? And don't forget the electron here as well. Explain the electron domain geometry of NO3 minus, okay? NO3 minus. So it has a 3 electron domain. That repel as far 100 degrees, and the geometry is trigonal planar, okay? So when the electrons, they're close together, they always tends to repel, and the far apart, but because of the this NO3 has a trigonal planar, so the further how far apart the electron can repel each other is only 100 degrees. Carbon forms many compounds. C60 and diamine are allotropes of carbon. Outline one difference between the bonding of carbon atom in C60 and diamine. Okay, so C60 bonded to 3C, and diamine bonded to 4C. Another answer, because it's only 1 point, you can also say C60 has pi free electron to delocalize, okay, their bond, but not for diamine, okay? Explain why C60 and diamine sublime at different temperatures and pressures. Diamine, this depends on the their bond, so how strong or what type of bond that they have. So for diamine, it has covalent network solid and sublimes at higher temperature and pressure. Sublimes means it turns directly from solid to gas. But for C60 has molecular structure with London force. State two features showing that propane and butane are members of the same homologous series. It means it comes from the same general formula, and then it differ by CH2 or repeated CH2. So the answer, it has the same general formula, which is CN H2N plus 2. CnH2n only is alkene, and it differ by CH2, or repeated CH2 unit. Suggest the fragment causing peak R in the mass spectrum of butane. I cannot answer this question because of the picture is being removed for copyright reason. Okay, next question. Describe a test that the expected result to indicate the presence of carbon-carbon double bond. Okay, carbon-carbon double bond. So to test whether it is alkene or alkane. So obviously it's add bromine water, and if you add the bromine water, the color from orange turns into colorless, because bromine water has an orange color. So when you add into alkene, it will turn into colorless. But if it's alkane, it will not change, the color will not change to it stays the same. So yeah, that's the answer. Butene reacts with hydrogen bromide. Draw the full structural formula of butene. So this will be between 2 and 3, butene, and this will be CH3, and this will be HN CH3, but number 2 in, and it has 4 C, that's why it's but. Write the equation for the reaction between butene and hydrogen bromide. So that would be CH3 CH double bond CH, and then CH3 reacts with HBr. So one will be to one C, and then Br to another C. So will be CH3 CH, and then H, and then C, and then H, and then Br and CH3. State the type of reaction is electrophilic, and you add them, so it's an addition. So molecules of atom that seek to accept an electron to form a new bond. So the bonds are the new bonds are formed here for the reaction electrophilic addition. Suggest 2 differences in the HNMR of butene and the organic product. Okay, so let me just write down the structure here. So butene, so C H H H and C H double bond H H and C H3. Okay, this is butene. And then we have the product, which is now CH and then H, CBr, and then H and CH3, which is 2-bromobutane. Okay, so we can refer to the HNMR in the data booklet. Okay, this is the, where is it, NMR? Yeah, this one, NMR data. So the first one, we see the difference that butene are asymmetrical, okay? So we have this CH3, this CH3 will be the same, okay, because symmetrical, and then this CH as well, this CH as well. So we have only 2 H environment, this one the same, this one will be the same. So for butene, it has 2 phenols, all right? And for the product, Okay, so this C attached to the C that has Br is not the same with the CH3 that is not directly attached to the C with that attached to Br. So this CH3 and then this CH3, the H on the C here and the H in on at the C here are not the same. All right, and it has CH2 as well, and then one H. So it has 4 phenols. Okay. And the other things that are the other thing that is different is the shift. So but2-in, it will be at 4.5 to 6 ppm because it has double bond. And for the product, that would be 3.5 to 4.4 because it attached to the bromine, right? So it's halogen. So that's another different. We need to find 2 because the point is 2. So chemical, let's see what's written here. Chemical shift, okay, is 4.5 to 6 ppm, and then chemical shift is 3.5 to 4.4 ppm. All right. Chlorine reacts with methane. Calculate the enthalpy change of the reaction, delta H, using section 11 of the data booklet. Section 11 is the average bond of enthalpy. Okay, this one. So as always, I always encourage to draw the lowest structure so you can see the how many bond, or see that we were bonded to H, so it will be clear. Let's see also like this, so you know that will be CH3 and then Cl and HCl. So as we know, this will be CH for CH and then Cl, Cl, and then 3CH, and you have C bonded to Cl and you have HCl. If you refer to the average bond enthalpy, so that would be 4 times 414 plus 242, and this will be times 414 plus 324 and 431. The total will be 1898, and this one, the total will be 1997. So delta H, this one minus this one, that would be negative 99 kilojoule. Draw and label an enthalpy level diagram for this reaction. It's a negative, so it's an exothermic. So exothermic, you know, the enthalpy will decrease, so it's negative. Therefore, the reactants, okay, is the enthalpy of reactants should be higher than the product. Okay, so this will be product and this will be reactant, and this will be activation energy, and this would be delta H negative. Okay, molten zinc chloride undergoes electrolysis in an electrolytic cell. Okay, so for electrolysis, always panic. So positive is anode, negative is cathode. Okay, anode always oxidation, cathode always reduction. Okay, cath red and ox. Okay, oxidation always lose electron, and reduction always gain electron. Okay, so now I will just write down here. So it's clear for you. So zinc chloride. So ZnCl2, that would be Zn2 plus and Cl minus. Okay, so it will go to the negative, and this one it will go to positive. Therefore, negative electrode will be Zn. Okay, the one that experience reduction would be Zn. So reduction, that would be gaining electron. So this will be 2 plus, produce Zn here. Okay, so for positive electrode, that would be Cl. So 2Cl produce Cl2 gas and 2 electrons. So it's balanced, 2Cl minus here. All right. Deduce the overall cell reaction including state symbols. Use section 7 of the data booklet. So ZnCl2, it's a liquid that produces Zn liquid as well, and chlorine gas. All right. So that's all for the explanation, chemistry paper 2, May 2022, time zone 2, standard level. I hope this video is helpful for you guys to do an exam preparation or revision. And if you find this video is helpful, again, don't forget to subscribe and let your other friend knows about my channel, so they can also benefit from my channel, or you guys can study together. And thank you for watching. Bye for now.